So we are looking at a global AI market that is currently sitting at right around $28.3 billion here in 2025. And basically every major projection has it just exploding past $150 billion by 2030.
Yeah, which is just a staggering influx of capital.
Right. It's
Yeah.
massive. But, if you are trying to figure out where exactly that money is going to flow, you can't just look at the glossy marketing materials coming out of Silicon Valley.
No, definitely not. You'd be totally misled.
Exactly.
Yeah.
You really have to look at the underlying mechanics. So, to see the future of this $150 billion economy, for today's deep dive, we've been combing through a massive stack of 2026 data.
And it is a huge stack.
It really is. We're talking over 60 peer-reviewed papers, a dozen industry reports, and the raw technical disclosures from, the heavy hitters like OpenAI, Meta, Google, and Anthropic.
Right, the frontier labs.
Yeah. And our mission today is simple. What we found in those sources is this massive, incredibly dangerous gap between the marketing hype of AI and the actual, mathematical reality of how these things work.
Which is such a crucial distinction because, the marketing narrative really wants you to believe these models are omniscient, reasoning entities, like they're actually thinking.
Right, like a sci-fi brain.
Exactly. But the technical disclosures tell a completely different story. Large language models are, at their core, just sophisticated probabilistic pattern matchers.
They're just guessing the next word.
Right. They predict the next most likely piece of a sequence based on, billions of texts they've consumed. And everyone listening to this probably knows they operate as predictive text engines. But what people miss is how that basic foundational architecture fundamentally dictates the unit economics of a global rollout.
Yeah, and that's the multi-billion-dollar question.
Exactly, because understanding that mechanism isn't just a fun exercise for a software engineer anymore. If you are an investor placing bets, a policymaker drafting regulations, or, if you're just trying to navigate your own career over the next 5 years, understanding this mechanical reality is really the ultimate playbook.
So let's get right into the raw materials of that market, because if we want to understand the profit margins driving that $150 billion forecast, we have to look at the fuel that's actually powering the engine.
Right, the raw input.
Yeah. And that fuel is not words. I think this is a huge misconception. These models do not see the English language the way you and I do. They consume what are called tokens.
Yeah, tokens are the foundational currency of the entire AI economy. The whole process is driven by subword algorithms, predominantly something called byte pair encoding.
Byte pair encoding.
Right. And you can think of byte pair encoding as a highly aggressive compression algorithm. So during training, it scans massive data sets, which is mostly the English-speaking internet, by the way, and it optimizes for the most common sequences of characters.
So it's looking for patterns in the letters themselves.
Exactly. It looks for common prefixes, suffixes, and root words. And because of that incredibly English-heavy diet, a standard English word is fractured into about 0.75 words per token. So a really short word might remain whole, but a complex one gets chopped into structural chunks.
And that chopping process, that's exactly what caused that famous strawberry problem that went viral back in mid-2024.
Oh yeah, that was everywhere.
It was hilarious, right? People were asking ChatGPT this incredibly simple question, just how many R's are in the word strawberry? And this multi-billion-dollar supercomputer kept confidently answering 2.
So confidently.
Right. And the whole internet was baffled as to how an AI that can literally pass the bar exam fails at kindergarten counting. But if you read the papers and understand tokenization, it makes perfect sense.
It really does.
It's like asking someone to count the exact number of eggs in a cake you've already baked. The model never sees the individual letters. It just sees the baked chunks of tokens.
That's a great analogy, actually.
Thanks. Yeah, for the word strawberry, the tokenizer chops it into est, raw, and berry. The model doesn't see the R inside the chunk raw or the 2 R's inside the chunk berry. It just sees 3 baked indivisible blocks.
Right, which proves these models are fundamentally character blind. Without an external tool, like giving it a Python calculator to manipulate the raw string of letters, the model simply cannot reason about orthography.
It just can't do it.
No. And it's a fascinating quirk of the architecture, sure, but the downstream effect is entirely economic. Because you pay API providers by the token. You are billed for every chunk the model ingests and every chunk it spits out.
And because that byte pair encoding compression was optimized primarily for English, The fuel efficiency completely collapses when you change the language.
Falls off a cliff.
Yeah. We are looking at wild variations in what the sources call token fertility. And, if you were a developer tuning in from India, you probably already know this pain point. The data shows that a Hindi speaker requires 3.62 times more tokens to express the exact same sentence as an English speaker.
Yeah, and the penalty gets even steeper. If you were serving users in Amharic, for example, it costs over 7 times more.
Wait, 7 times more just to say the same thing?
Over 7 times, yeah. Because the tokenizer doesn't recognize the roots and suffixes of those languages efficiently, right? So it just shatters the words into tiny, inefficient fragments, sometimes down to individual characters.
So if I'm like an enterprise SaaS company building an AI product and I want to roll it out globally to tap into that $150 billion market,
Yeah.
my cloud computing bill in Ethiopia is instantly 7 times higher just because of the language.
Exactly. It acts as a massive regressive tax on emerging markets. You basically cannot project global software margins using English token economics. It destroys the unit economics of a global rollout.
That is wild.
And beyond just the financial cost, the performance degrades heavily because the model is stretching its limited memory over all those fragmented pieces.
Okay, so if tokens are the fuel, and they are incredibly expensive, especially for non-English languages, the natural engineering response is to try and cram as much of that fuel into the engine at once.
Right, to give the model more context without requiring multiple back and forth prompts.
Exactly. Which is exactly why we're seeing this massive industry-wide arms race over the context window.
The attention economy of the AI itself. The context window dictates how many tokens the model can hold in its active memory at one single time.
And the scale of this jump in the literature is just breathtaking. I mean, we went from GPT-3, which could hold a modest, 2,048 tokens?
Yeah, roughly 2,000.
To models like Gemini 1.5 Pro, boasting a 1 million token window. And the enterprise sales pitch writes itself. They were telling Fortune 500 companies, hey, don't bother spending millions organizing or cleaning your data. Just dump your entire software code base or hundreds of massive financial 10K documents into the prompt all at once, and the AI will synthesize it perfectly.
Yeah, that is absolutely the promise being sold to boards of directors globally right now.
But hold on, though, because if I can really dump a million tokens, like an entire decade of a company's financial history, into a single prompt, why hasn't every junior corporate analyst on Wall Street been fired?
Well, that's the catch, isn't it?
Right. The marketing implies the AI can read and analyze all of it instantly.
But the reality falls apart due to a structural limitation in the math, which researchers call the lost in the middle phenomenon.
Lost in the middle. Okay, tell me about that.
So, to understand why a massive context window doesn't equal massive comprehension, you have to look at the attention mechanism inside the transformer architecture. When a model processes text, it doesn't just read linearly like a human does, word by word.
Okay.
If you add one new word to a sentence, the model has to calculate how that new word relates to every single other word it has already read in the entire document.
So it's mapping the relationship of every token to every other token.
Exactly. And this requires what is called quadratic computing power, meaning if you double the size of the document, you don't double the compute required, you quadruple it.
Wow. Okay, so it gets heavy fast.
Very fast. As the window expands to hundreds of thousands of tokens, the math just begins to break down. The model's attention becomes mathematically diluted.
And the sources actually outline a brutal real-world test of this from a multinational bank, right?
Yes, this is a great example.
Yeah. They took Claude 2, which at the time had a 100,000 token window, and they fed it an 80,000 token chunk of quarterly earnings transcripts and 10K filings from their portfolio companies.
A huge data dump.
Right. And they gave a classic analyst task, which was just extract all the risk factors related to supply chains and foreign exchange.
Which sounds like a seemingly perfect use case for a massive context window.
Except the model missed 12 out of the 45 relevant risk factors.
A third of them.
Yeah. It didn't flag them. It didn't hallucinate new ones, which is good, I guess. But it just completely glossed over them. And the crazy part is almost all of those 12 missed risk factors were buried right in the middle of the documents.
Right, because the model recalled the beginning of the prompt perfectly, and it remembered the very end, but the middle was basically a black hole.
That is terrifying if you're relying on it for financial compliance.
Absolutely. The research is definitive on this. Naively throwing compute at a problem, a brute force method they call context stuffing, simply does not work for enterprise accuracy.
Context stuffing.
Yeah, and the effective utilization and recall drop precipitously after about 10,000 tokens for any task requiring dense reasoning.
So treating the context window like a giant garbage disposal for unstructured corporate data is just bad engineering.
Very bad.
And when a model fails to extract facts reliably from these massive data dumps, we run headfirst into the single biggest threat to that $150 billion market cap, hallucination.
The hallucination tag.
Right. If you are an inventor looking at a SaaS startup right now and their entire product is just a thin wrapper on a standalone LLM, you should be terrified of the hallucination tag.
Because businesses cannot function on probabilistic guesses. If you can't trust the output, the adoption curve just dies. I mean, look at the highly evil benchmark data in our sources. It's sobering.
Yeah, even in heavily guarded state-of-the-art models, the factual error rate hovers around 3%.
Which is still too high for a lot of enterprise use cases.
And in legacy or smaller models, it's a staggering 27%.
Right. You cannot run a logistics supply chain, a legal firm, or a hospital on software that is confidently wrong even 3% of the time, let alone 27.
And the telehealth case study in the research illustrates that danger perfectly. So there was this startup evaluating models for an automated triage symptom checker.
Right, for medical use.
Exactly. They ran 1,200 synthetic patient symptom descriptions through GPT-4o and Claude 3 Opus in a zero-shot test.
Meaning they just fed the symptoms into the raw model and asked, what should I do? Without any extra guardrails or tools, just the raw model.
Yeah, and the results really highlight the divergence in model training. Yeah. GPT-4o confidently provided a specific and potentially highly dangerous medical diagnosis in 7.2% of the cases. Yeah, it would suggest things like, oh, this could be early-stage shingles. And statistically, based on the web data it trained on, that might be a highly probable completion of the text sequence. But medically and legally, it violates every safety guideline in existence.
Oh, absolutely. A 7.2% chance of handing out an illegal medical diagnosis is the fastest way for a startup to get sued out of existence.
No kidding. But Claude 3 Opus handled it differently, though.
It did, because Claude 3 Opus was trained using Anthropic's constitutional AI.
Which means what, exactly?
It basically means they bake explicit behavioral constraints directly into the model's weights during training. So in that same exact test, it safely recommended seeing a human doctor every single time. It just refused to guess.
Okay, so that divergence is forcing the entire market to pivot. The industry is realizing that treating a standalone LLM like a genius oracle is just a recipe for disaster.
The very expensive disaster.
Right. So if the models inherently want to guess, how is the market actually solving this? The answer, which is driving the biggest investments right now, is the shift away from monolithic models toward what are called compound AI systems.
Yes. This is the real evolution of the architecture. You know, for a long time, the dominant analogy was treating the LLM like an articulate intern.
Which kind of made sense at first.
It did. But from an engineering perspective, a much better way to visualize a compound AI system is comparing the LLM to a computer's CPU. The market realized the language model isn't the whole computer, it's just the logic board.
Oh, I like that.
Yeah, it processes information, but it has no persistent memory, and it gets incredibly hot, meaning it hallucinates. So to make it useful for an enterprise, you have to solder it onto a motherboard. You add RAM in the form of vector databases, and you add a cooling system in the form of verification loops.
Let's break down that RAM piece, because vector databases keep coming up in the data as a massive growth sector.
Huge growth.
Yeah. A vector database takes your company's proprietary PDFs, emails, financial records, and it turns them into searchable numbers. It maps human concepts into a mathematical space. So the words revenue and income end up physically close to each other in this giant mathematical grid.
Right. It creates semantic proximity.
Exactly. So when the LLM needs an answer, it doesn't just rely on its own internal faulty memory. It searches the vector database, pulls the exact authorized paragraph, and then uses its language skills to summarize it.
And that process is what we call retrieval augmented generation, or AIR. You can strain the language model by forcing it to look at an external verified filing cabinet before it ever speaks.
Right, the RAM.
Exactly. And then the verification loops, the cooling system in our analogy, act as a secondary, smaller AI model whose only job is to grade the primary model's answer before the user ever sees it.
So it's double-checking the work.
Exactly.
And the defense contractor case study in the 2026 data shows exactly why this is displacing the cloud API market.
This is such a fascinating shift.
It really is. Yeah. So this contractor had highly classified internal intelligence reports. And for obvious security and regulatory reasons, they could not pipe that data out to a commercial cloud API.
Right. You can't just send top secret data to OpenAI's servers.
Definitely not. So instead, they took an open source model, Meta's Llama 370B, which is relatively small and efficient. They fine-tuned it, and they hooked it up to their own internal vector databases using a RAG pipeline entirely on their own secure on-premise servers.
Right. And by using a compound system constraining the model with retrieved data rather than hoping it memorized the facts during training, they achieved 93% accuracy on complex entity extraction tasks, which is incredible.
It is. But the financial breakdown is the real story here, I think.
Oh, without a doubt.
Because the total hardware cost to buy the server racks and run this pipeline themselves was $580,000.
Which sounds like a lot of money to the average person.
Sure, it sounds like a lot until you look at the alternative. If they had tried to buy a proprietary cloud equivalent with the massive security overhead required for classified data, the price tag was $4.2 million a year.
Every single year.
Yeah. And that $4.2 million isn't just compute. That's paying for the cloud provider's API markup, the exorbitant network data egress fees for moving classified files, and the premium for secure single-tenant cloud environments.
It adds up fast.
So buying the hardware outright for $580,000 and running an open source model fundamentally disrupts the cloud revenue model.
It absolutely does. And this leads us to the critical market question. If the future enterprise AI relies on on-premise compound systems leveraging open source models, who is actually going to capture the lion's share of that $150 billion?
Right. Where's the money going? Well, the research applies Porter's 5 forces to analyze the market tiers, and the dynamics are shifting violently.
Very violently.
At the top, you have Tier 1. These are the frontier labs like OpenAI, Anthropic, and Google. Their competitive advantage is purely their compute moats. They're spending tens of billions of dollars to train the biggest possible foundational models.
Right. But Tier 2 is entirely undercutting them. The open source and commercial challengers, companies like Meta with their Llama models and Mistral out of Europe, they are causing massive commoditization of the actual intelligence.
The price collapse is historic. I mean, look at the numbers. The cost to process 1 million tokens dropped from $20 in early 2023 down to just 30 cents by mid-2025.
30 cents, it's almost free.
It's a race to the bottom for anyone selling raw API access. So if the brain of the AI is becoming a cheap commodity, the smart money is migrating elsewhere.
Exactly. The sustainable margins are moving to the orchestration layer.
The orchestration layer.
Yes, the infrastructure surrounding the model, the companies building the vector databases, the inference time routing software, and those specialized verifier models we talked about. Those components are becoming the sticky, high-margin software businesses.
But even those businesses are facing massive looming threats that could throttle the entire ecosystem's growth.
Yes, there are some major speed bumps ahead.
Right. I mean, the regulatory hurdles alone are daunting. The EU AI Act compliance is forcing companies into expensive transparency and risk reporting protocols, effectively raising the barrier to entry for smaller orchestration startups.
Which usually favors the big incumbents.
Exactly. But the two absolute biggest bottlenecks we found in the data are physical, not legal.
Yeah, and the first is data exhaustion. The models require exponentially more data to improve, but the report projects, we will literally run out of high-quality, human-generated training data by 2027 or 2028.
Wait, run out? Completely?
Completely. We've effectively scraped the entirety of the useful internet already, and when you start training models on synthetic data, meaning data generated by other AIs, you risk what's called model collapse, where the outputs become highly repetitive and degraded.
So it just eats its own tail and gets dumber.
Exactly. We hit a wall on human knowledge.
But the ultimate bottleneck, the one that physically dictates the speed limit of this entire $150 billion market, is hardware and energy.
The physical infrastructure.
Yeah. NVIDIA currently controls roughly 85% of the AI GPU market. The entire global supply chain is bottlenecked by the production of these specific chips. And even if you have the chips, you have to power them.
And the physics of that situation are terrifying. Training a frontier model like GPT-4 consumed over 50 gigawatt hours of electricity.
That is insane.
And that is just for the initial training run. As millions of enterprise workers and consumers query these models daily, the inference costs just soar. Data center growth is actively threatening power grids globally.
I mean, the energy required to run these stochastic engines at a global scale is pushing our infrastructure to the absolute brink.
It really is.
So if you take one thing away from this deep dive, let it be this. Large language models do not think like you and I do. They are incredibly powerful, highly complex statistical engines that are strictly bound by the math of subword tokens, the limits of attention mechanisms, and the brutal physics of global power grids.
Exactly. Treating them like omniscient human beings is simply bad business.
The next 5 years of this market will not be won by the company with the single biggest model. It will be won by the organizations that engineer reliable, compound AI systems.
Yeah, whether you are prepping for a boardroom meeting to decide on a massive software procurement or you are just navigating the tools available in your own daily workflow, you have to build a verification-first mindset. Assume the logic board will run hot and guess, build the cooling systems to catch it.
Well said. And as we look further over the horizon, the research points to a future that feels a bit like science fiction, to be honest. But the capital is being deployed right now. With AI energy consumption spiraling out of control, we are on track to see the first nuclear power plants built specifically and exclusively to power AI data centers.
Which is wild to think about.
It's mind-blowing. And as the technology inevitably evolves past this current assembly language of cognition, moving from just predicting the next word to neurosymbolic AI, which aims to combine this statistical learning with hard-coded logical reasoning, the legal and social landscape is going to fracture.
Oh, the legal battles are going to be unprecedented.
Yeah. Keep your eyes on the year 2032. That is when legal analysts project we might actually see the first legitimate court case arguing for a highly autonomous neurosymbolic AI system to be granted a limited form of corporate personhood.
Personal?
Yeah. It fundamentally changes the definition of what a tool is. Something for you to chew on the next time you casually ask a chatbot to draft an email for you. You might be admiring the sleek paint job, but the engine under the hood is rewriting the global economy.
Just make sure you always check its math.
Always. Thanks for diving deep with us.